In this video, we are going to talk about space, so before starting this video, please like this video, and subscribe to our channel for future updates. Let's start the video. We Earth-born beings have been venturing into space since October 4, 1957, when the Union of Soviet Socialist Democracy USSR launched Sputnik, the first artificial satellite to circle Earth. This passed during the period of political hostility between the Soviet Union and the United States known as the Cold War. Humans began the physical inquisition of space during the 20th century with the arrival of high-altitude balloon routes. This was followed by crewed rocket escapes and, also, crewed Earth Circle, first achieved by Yuri Gagarin of the Soviet Union in 1961. A common description of space is known as the Kármán line, an imaginary boundary 100 kilometers 62 country miles, above the mean 7 seas reach. In the thesis, once this 100 kilometers line is crossed, the atmosphere becomes too thin to give enough lift for conventional aircraft to maintain flight. Space inquisition allows us to prove or rebut scientific theories developed on Earth. Studying the solar system, for example, has brought us the perception of alike miracles such as gravity, the magnetosphere, the atmosphere, fluid dynamics, and the geological expansion of other planets. Space helps people learn to more look out for the Earth. Scientists can study changes in the climates of other globes, similar to Venus and Mars. This data can help them understand climate change on Earth. Comparing the Earth to other objects in space also helps people realize how special and precious our Earth is. In space, there's no air or water, so the only way to lose heat is by radiation, where your warm and wriggly atoms release energy directly into space. This is a slow process, so you'd die of oxygen loss long before you'd notice the cold wave. Stardust, it's the utmost important stuff in the universe. Outside space isn't fully empty, it is a near-perfect vacuum containing a low viscidity of patches, generally a plasma of hydrogen and helium, as well as electromagnetic radiation, glamorous fields, neutrinos, dust, and cosmic rays. During the Big Bang, all of the space, time, matter, and energy in the universe were created. This giant explosion hurled matter in all directions and caused space itself to expand. As the universe cooled, the material in it combined to form worlds, stars, and planets. Space is a near-perfect vacuum, meaning it has exceedingly many patches. There is nearly nothing in the space between stars and planets to smatter light to our eyes. In space, no one can hear you scream. This is because there's no air in space, it's a vacuum. Sound waves cannot travel through a vacuum. External space begins about 100 kilometers above the Earth, where the shell of air around our globe disappears. The universe is at least 250 times larger than the observable world, or at least 7 trillion light times across. To come to a space scientist, one should retain applicable education in pure wisdom or engineering disciplines. ISRO novitiate candidates with Ph.D. in astronomy, physics, and mathematics, along with engineers in disciplines similar as mechanical, electrical, electronics, and computer wisdom. The first beast to make an orbital spaceflight around the Earth was the dog Laika, aboard the Soviet spacecraft Sputnik 2 on November 3, 1957. On October 4, 1957, the USSR launched Sputnik, the first artificial satellite to route Earth. Presently, about 3,000 officially enrolled objects are still en route, and the utmost of them are 10 centimeters and larger. Sound journey through the vibration of particles, and space is a vacuum. On Earth, sound travels to your ears by way of vibrating air motes, but in near-empty regions of space there are no or really, very many, patches to vibrate, so no sound. However, the sky between the stars appears dark indeed, if you get down from the city lights and look up. Above the Earth's atmosphere, external space dims indeed further, fading to an inky pitch dark. And yet indeed there, space is absolutely black. The line separating the atmosphere and outside space is called the Kármán line. The term outside space and the universe are roughly original, except that outside space refers only to the area between planets, while the universe encompasses globes as well. The universe is about 13.8 billion times old. Despite what you might assume from this image, the utmost of the universe is empty, stellar space. But the reason the universe is this large moment is that it's expanded and cooled to reach this point. Indeed, today, the universe continues to expand at a tremendous rate, roughly 70 kilometers/s/mpc. In space, no one can hear you scream. This is because there's no air in space, it's a vacuum. Sound swells cannot travel through a vacuum. Outside space begins about 100 kilometers above the Earth, where the shell of air around our Earth disappears. Fires cannot start in space itself because there's no oxygen, or indeed anything further, in a vacuum. Yet inside the confines of spacecraft, and freed from graveness, flames bear in strange and beautiful ways. They burn at cooler temperatures, in unknown shapes, and are powered by unusual chemistry. Space is not curvy, they will nothing meet or drift away from each other. A flat universe could be fathomless, imagine a 2D piece of paper that stretches out every. But it could also be finite, imagine taking a piece of paper, making a cylinder, and joining the ends to make a torus donut shape. The Kármán line is an approximate region that denotes the altitude above which satellites will be suitable to orbit the Earth without burning up or falling out of orbit before circling Earth, at least formally, Bossert said. It's generally defined as 100 kilometers 62 long hauls, above Earth, Eagle added. Ever since its launch in 1990, this telescope has been one of the most successful advances in space research disquisition. Being 569 kilometers above the Earth's face, this technology avoids atmospheric warping, allowing it to bring thousands of jaw-dropping images back to Earth. Every object in space exerts a gravitational pull on every other, and so graveness influences the paths taken by everything traveling through space. It's the size that holds together entire galaxies. It keeps planets in the circle. It makes it possible to use mortal-made satellites and to go to and return from the moon. The early period of space exploration was driven by a space race between the Soviet Union and the United States, the launch of the first man-made object to circle the Earth, the USSR Sputnik 1, on October 4, 1957, and the first moon wharf by the American Apollo 11 craft on July 20, 1969 are frequently taken as landmarks. Space is the three-dimensional area around you, including the universe. A case of space is where stars and planets live. The first human in space was the Soviet cosmonaut Yuri Gagarin, who made one route around Earth on April 12, 1961, on a flight that lasted 108 minutes. Scientists now consider it doubtful the universe has an end, a region where the galaxies stop or where there would be a hedge of some kind marking the end of space. But nothing knows for sure. In space, people usually witness environmental stressors like microgravity, cosmic radiation, and social isolation, which can all impact aging. Studies on long-term space trips frequently measure growing biomarkers similar to telomere length and heartbeat rates, not epigenetic aging. The light second is a unit of length useful in astronomy, telecommunications, and relativistic physics. It's defined as the distance that light trip in free space in 1 second, and is equal to exact meters, foot. This form of time dilation is also real, and it's because, in Einstein's theory of general reciprocity, graveness can bend space-time, and therefore time itself. The nearer the clock is to the source of gravitation, the slower time passes. The further down the timepiece is from graveness, the faster time will pass. Earth takes 365 days to make one circuit. The closest Earth, Mercury, takes only 88 days. So what do you think of our video? Let me know in the comments section below. If you enjoy this video and want to hear from me again, be sure to hit that subscribe button before you go. Thanks for watching.